All right, I'm Preston Marshall, giving a talk about OTP, RethinkDB, and Elixir channels today. Hopefully, be pretty entertaining. If you have like a question or a comment or something like that, just jump right in. I believe on a group where we can do that. So, stump the chump. So, my background. I've been riding the rails with Ruby since about 2008. I got started doing emergency management software, how to start a idea, just kind of taught myself how to program in Ruby, and the rest is kind of history. I did some healthcare stuff, as my bio and the meetup.com thing said, but I initially started using Erlang by eJabberD and RabbitMQ back in 2008, and so I bought the concurrent programming with Erlang, or whatever what's the image on it, the things that you juggle, or hacky sack or something like that. Anyway, I bought that and I started reading through it, and I really just didn't have any idea what was going on. I had only been doing Ruby for a few months, and Erlang was just too much of a paradigm shift from anything I'd ever seen before. That didn't really click. And then on top of that, everybody says the syntax, blah, blah, whatever. So it never really clicked. By the way, my accent is from Athens, Alabama, by way of Birmingham. I just moved here 2 months ago, so I get a lot of questions on that. But let's talk about some of the reasons that Elixir actually made sense. The syntax issues are gone. It's very nice. It's very close to Ruby. At least it feels like it's close to Ruby. I feel like to really write Elixir, you kind of have to fully understand how you would write Erlang, but it's enough. It's close enough that where you can kind of, oh, well, this looks really similar. I don't have to end the lines with periods to get started and jump in. Also, the build tools are excellent. Some of the best I've ever used. Just a lot of the problems that you would have to solve, or a lot of the pitfalls that you'd have, with Maven and Java, or Bundler. Bundler does a good job of it after many, many years of, not. And then NPM. But Mix and Hex and those things put together, they have a really good build environment. And, even things as simple as the error messages. I had a conned statement the other day, and I was in case mode in my head, and Elixir told me that instead of an underscore, I probably wanted a true as the catch-all. I was like, oh, well, that's awesome. So a lot of little stuff like that, reminds me a lot of when I was getting started in Ruby, about being very friendly towards a developer. To me, that's really important, because it increases your productivity, and you feel like you can get stuff done with type things that everybody deals with from day to day. The other great thing about it is macros. I've kind of stumbled my way into writing a DSL. I'm not sure it's the best code yet, but I'm hoping that down the road I'll be able to share it. Basically it actually generates functions using the binary pattern matching in Erlang or in Elixir to basically map different types of packets into maps, and then you can use the protocols to do whatever you want to with them. And then last but not least, one of the reasons we're here today is OTP. The wrappers for it, GenServer, GenEvent, they used to have GenFSM a long time ago, Supervisors, some other stuff on top, task supervisors, agents, a lot of good stuff in there. So let's talk about OTP. OTP stands for Open Telecom Platform, has nothing to do with telephony or anything like that. Funny story, I actually worked a lot in voice over IP and telephony before learning programming. So Erlang was like something you always heard about. It's actually a measure of voice quality, I believe, or maybe the load of a system. There was a guy named Erlang. He was a statistician way back in the day, and so I heard of Erlang there before the software language. OTP is humongous. I haven't even scratched the surface of my own knowledge of like where you can go with it. I've only been in this for a couple months, but I feel like you could spend years and not ever touch all the stuff in OTP. I mean, it's basically Erlang, the interpreter, the compiler, the library. The standard library has stuff in it like an LDAP client and an SSH client, you know, some of the things that you would expect, but maybe not from a language that's 25, 30 years old. So we're just going to barely scratch the surface of OTP today, but generally when you hear OTP, people are talking about GenServers and supervisor trees. So most commonly used libraries, behaviors, that's kind of what OTP is. Supervisors, GenServer, GenEvent, GenFSM. So those are some of the big ones. You can go to Learn, use some Erlang for great good, and it gives a really good overview. That the GenFSM, from what I've seen, is probably too opinionated for most things you want to use finite state machine for. But the chapter in that book is excellent. You can not know Erlang at all and go to that book and just read all the different scenarios and see the graphs of how things can go wrong. And it's really interesting to think about those problems. And we actually solve a lot of those problems because we're dealing with distributed computing and dropped packets and things like that. So that's a very real problem to have to worry about. And implementing that stuff yourself, you can, you shoot yourself in the foot. I did that earlier today. I believe with Erlang being an idiot. So let's start out with supervisors. They're generally formed as trees. Supervisors can have supervisors inside of them, so they supervise supervisors. And if a supervisor blows up, the supervisor that's supervising it will restart it, unless it's the top level, and then it will go down. There's lots of restart strategies and knobs to turn. Intervals, how many times. If the service is flapping, 30 times in 10 seconds or something like that, then it'll permanently fail, and that actually kills the supervisor. And then you handle that up the tree. For the restart strategies, there's one for all, simple one for all, one for many, I think is one. Basically, it just lets you control how, if one process or one worker that is being monitored by that supervisor dies, do you want to restart all of them? Do you want to restart just that one? Do you want to have something more complex than that? The documentation has all of the things in there, and it also lets you specify how do you want to kill the other supervisors. And there is an option called brutal kill, which, reading the standard library, I think it's interesting to see stuff like that. So another thing with Elixir is we have tasks. And tasks are just a kind of a sugar wrapper around processes. Just basically let you pass these things around, and it's really just a reference to what it is and a PID. And then they built some other stuff on top of that, but the task stuff is great. And then, like I said, you can supervise other supervisors. So this is a running application. The observer application, which is built in Erlang, you can just start it up on a remote node. It actually will run locally with X11, or actually no, it doesn't even require that. And you can go into it and get a list of all the applications and click on them. And this is I believe this is the kernel application. So these are all different things. These are processes, 9, 10. This is a supervisor. This supervisor is supervising these other processes. One of them is another supervisor, and it goes to do its own thing. So all of these supervisors have different strategies for restarting, monitoring. You can handle, alerting and everything at a very granular level through those. So with this, you can build very reliable systems that, can handle the world blowing up, burning. You can also handle partial failures. There's a blog called This OTP Life, and it is a fairly anti-Elixir blog. But, everybody is, and a lot of stuff, once you start learning about Elixir and Erlang, you'll get the inside jokes and think it's hilarious, just like I do. So the big part about that you've probably heard of before is GenServer. GenServer is a generic server. It's a you have this name for something, and this name for something says that you implement these certain different callbacks, and it's kind of like the compiler will check whether you're doing the right thing, and it lets generic code work with those same behaviors. It's kind of an old school protocol almost. I think a lot of people get them confused, and I'm not sure I understand it well enough to explain it, but it's a way to write generic code and have it work with different types of things. So this is a naive GenServer. I took this code from Elixir in Action by Sasha Urich, I believe is how you say his name.
Sasha Urich.
And this is available, all the code for the book is available on GitHub. It's probably the best book if you're just trying to like get started with Elixir and you know, actually write production code with it. The Pragmatic Programmer's book is also very good. I feel like it's more about getting you excited about things rather than saying this is how all this stuff works. They're both great. Take a look at them. They're pretty short reads. So we'll go through this real quick. Basically, this is the app layer implementation of a key value store. It's very simple. Start the process. You would put something in there. Put something in a whatever the state that it uses. Hashdict. So, and as an aside, for the people that have been using Elixir for a while that didn't see it, hashdicts have basically been completely replaced by maps in Erlang 18. The performance advantage of hashdict is pretty much gone from what I've seen, so just use maps. But basically on start, this starts the initial state. Put, get, you can, you know, call those to put things, to get things out of that hashdict. And you'll pass in the PID. And so these handle calls basically use the server process, and the server process will call these handle calls. And this sounds very convoluted because you don't actually have to do any of this. This is the server process. This is the really generic part that Erlang provides for you, and it's very, this is a very, very simple version of it. Basically, it starts the module and in a new process with the initial state, calls an it first, and then it loops. Loop basically receives messages and sends them to the process that was started in it and then restarts. That's fairly basic stuff, but you don't want to have to do that every time. So with GenServer in Elixir, you just say use GenServer. And the use is a macro I mentioned earlier that basically, in my opinion, it kind of takes over all the different metaprogramming needs and imports and all that you need in Ruby. You can really take care of a lot of that with use. Now, you know, it's a macro, so you can do whatever. But it's really simple because you can say, you see use and you say, oh, well, how does that work? Well, you just go to the main file in lib that defines that main module or whatever you're using there and look at the using macro, and you can just go from there. But GenServer, use GenServer. It defines some generic codes and default fallbacks, error handlers, things like that, that are different from the default ones. Basically, the GenServer behavior, GenServer kind of provides all the stuff for that. So like if you send a message to this, it has to be handled somehow. Well, GenServer will raise an exception and it'll die, but it'll actually compile. So every GenServer will probably have this type of thing. The cast here is just there for demonstration. But start, so to start this up, you would call GenServer start link, which calls this start command. Actually, that starts that. The start calls the init. Basically, init sets up the initial state just like we saw before. It's a hashdict. Then it starts that loop process, just like it did in the preview to this. The big difference is these handle casts and handle calls Those are behavior callbacks from GenServer. And handle cast is an asynchronous version. So as you can see up here, GenServer cast calls the PID, and then this is actually a pattern, and this will pattern match right here. So handle cast, when this is called, it's just going to say, boom, send a message. That's basically all it does. As soon as it sends the message, it returns okay. When this gets it, it'll match this right here. The key and the value, it'll match that from the tuple that you sent. Then it'll put it in the hash stick. And that hash stick is the second element in that tuple that's returned. This says there's no reply to that sender because it can't reply because it doesn't know where it really came from. And then there's a hash stick put. And this hash stick put takes the existing state, puts the key in it with that value, and returns the entire hash stick. So that actually goes back into the state, starts looping again. Now, while this is running, only one of these things can run at once. So you don't have to worry about two of these running at once and it corrupting your state. That's the key to this, is when you're running this state right here is specific to just this one process. Because after all, this is just one process running at once. So it can only be doing really one thing at once. So that's cast. Call is basically the exact same thing. This underscore right here, catch all, is the from. That's who actually called this message. I really haven't had that big of a use for it yet because you can apply to the caller with a value. And so this is going to say, reply to the caller with get, and that just gets the response that you're going to send back to the caller. And then we're just going to have the same state. So you could also change the state in here if you wanted to keep track of the PIDs that have called you or whatever. You could use that caller, the from is what I call it, and put that in state. But there's no need for this simple example. So these are the server implementations. And then these are the client implementations. The client implementations usually just wrap the GenServer. You can put like a better interface on it or provide default values for certain different things. Like if you have a globally registered namespace, but you need to do type of dependency injection for your tests, it's always going to be one thing unless you provide a PID that it needs to send this to manually. And you can do that, or you can kind of chain these together and create multiple things through them. That one thing right there is what both of these things were. So it does the exact same thing. Well, this might actually do more. So GenServers really are the building blocks of almost everything in Erlang. It's kind of a little bit higher level than the processes and spawns and things like that. But at the end of the day, if you need to write some sort of server, and a lot of things can be thought of in terms of servers, you're going to use GenServer. And so Phoenix framework uses a lot of GenServers. And if you generate a Phoenix application and you go into Observer and look at that apps list like I was talking about earlier where the screenshot came from, you can see the various things that are GenServers. You'll see if they're idle, it has a loop that's called in there. And that's just the GenServer loop. So Phoenix is quickly becoming Rails for Elixir. Even though it's nothing like Rails, it's much simpler. It's much easier to figure out what's going on in Rails just because of its simplicity. I like it a lot better. It has basically routing, templating, models, the standard things that you would expect. You don't really have to use any of those if you don't want to. You can change it. And then finally, last but not least, channels. So channels are really awesome. They're just another behavior, quite a bit like GenServers. And I'm not exactly sure of the exact implementation of channels, but I would bet that they probably are a GenServer, or there's multiple GenServers that are in the stack behind it. But essentially, they're bidirectional controllers. And so what that means is you can send messages in, you can send responses back, but you can also send responses to the client without the client talking to you. It just moves both ways. And you can also send things over channels using the broadcast method through the pub sub functionality. So like if you have a this is actually, I'm kind of fast forwarding a little bit, but if you needed to push something all the way up to the client from a GenServer, something pulling off of AMQP or something like that, you would set that up and then you would just broadcast it. And I was pushing HL7 messages from healthcare up to the browser just kind of as a proof of concept. So that's how I did that before I knew about RethinkDB. But basically, this is a persistent connection with the client. The browser, mobile, I don't think there's an iOS client for it yet, but I know they're working on it. And then IoT, Internet of Things. So they're working on, from what I've heard, I haven't seen any code yet, a co-app, which is one of the Internet of Things like binary low layer protocols. So to me, it's really kind of, Phoenix seems like the channels seem like the next generation, like connected world. You're not doing a whole lot of polling. You can. It can handle it just fine, but you don't have to. The channels use WebSockets, but that transport is actually configurable. They also have a long pole transport, and the long pole just is a controller that is a normal Phoenix controller that just keeps the connection open and lets you push to it. And so behind the scenes, you don't, that's what's going on, but you don't have to know that that's any different. And so, if you wanted to implement one for RabbitMQ, AMQP, whatever, MQTT, whatever protocol du jour there is, then you can use that. So my solution, well, I was kind of going looking for a solution. I don't exactly remember how I stumbled across RethinkDB, but I remember reading a blog post about it, a few months ago, maybe a year ago, and it was kind of in the back of my mind. I was like, oh, that's pretty cool, whatever. Well, basically, RethinkDB is a JSON database from the ground up. I guess you could call MongoDB that as well, but RethinkDB seems to be taking kind of like a durability first perspective. And I think Mongo's fixed a lot of their issues that they've had with durability, but it does lost the trust of a lot of people. So RethinkDB still has that trust to burn, I feel like. But it's a JSON database from the ground up. For the people in here that are from the .NET world, Link. Link is basically a way that you can write queries for your database in a generic way in the native language that you're writing. So it looks a lot like Ecto does. And Ecto, I think the queries were kind of designed to look like Link. But RethinkDB, basically the client driver implements this binary protocol, and it builds up it builds up the query to send to the server in binary. So instead of having the server build it from like a plain text representation, it builds it it runs the query in binary. So what that gets you is you just write the query in your native language with lambdas and functions and all that. It also does scaling, sharding, replication across data centers, and with the new beta, it's Raft enabled. For the people that are distributed computing nerds, that's like the latest and greatest algorithm. And then for what we're here for, it does Changefeeds. The Changefeed, the real-time stream of changes. Something changes in the database, you get an update for it. New row, change to an existing document, or just an arbitrary query that you have written. It can have filters, transforms, all sorts of stuff on it. The one thing that it does not do yet, much to my disappointment, is it doesn't do aggregations, but they're working on it. So like if you wanted to keep a count that continually updated, so you wanted to have a count of however many messages you've received and have it change and send a message every time that count changed. From my experience, that doesn't work yet. I haven't found documentation that says that it is not supposed to, but there are issues on their bug tracker to support reduces and aggregations live. So, but what they have so far works very well together. So this is an example Changefeed query. So for the people that don't know, don't follow Elixir Sips. Elixir Sips is a short screencast of Elixir, how-tos and just quick little bites of information, ways to do cool things from Josh Adams, who's actually from Birmingham. But he, in Elixir Sips, has Elixir Friends app that he wrote. It's pretty simple. It's just kind of used to demo. I think it's like a 3 or 4 part episode series, but it uses Postgres, and so I've just kind of taken a look. I took a couple hours to make it work with Rethink and figure out all the issues with the RethinkDB driver for Elixir. There's 2 of them. Make sure to use the one that supports the 2.0, and I can't tell you which one because they're called RethinkDB Elixir and Elixir RethinkDB. So good luck. But anyway, just a quick step through this. Do your imports requires Lambda, the query stuff. That way we don't have to type the whole thing out every time. Specify your database here, and this is all written in Elixir. This is not like another query language. So you specify your database here, specify your tweets table here, and then you say that you want the changes for that. So that changes, that's going to build a query, and then it's going to send this connection to run. And the connection's multiplex. So all the things in that go across this one connection. And then I'm typing that into a stream where I just take every one out of there, and then I do enum.each on the change. That may not be 100% the most efficient way to do it, but it worked. So that's what we're going with. Basically, you have an old val and a new val when a change comes across, and the new val just pattern matching that into post from the change. And I'm actually just rendering some HTML here. Usually you would probably render JSON or protobufs. But this just renders HTML, and it pushes across a socket. Now, one thing that did get me on this, if you ever do this, you have to use this render to string, because if you just try the regular render, it does some weird escaping stuff, and it's not what you want. So at the end of that, it pushes that socket, and I'll show you the channel once we've kind of gotten through all this. It pushes this HTML message through the socket, which is something that gets set up as part of the channel. The tweet is the event name, and then this is the payload. So we're just saying view HTML. So to show you where that comes from or how that's used, set up, you have to do a little bit more than this with channels, but this is the kind of the different part of it that doesn't get generated for you. So a lot of this part is basically I said connect to the socket, and you have to add the route in your router, but that's really easy. The generator say receive OK, and say we subscribe to tweets when we connect. This says on the tweet event, run this function. And all I'm doing is using jQuery to prepend message.view. Messages the payload, views the HTML. That's fairly straightforward. So we're going to attempt a live demo. And another window I'm just starting, Phoenix server is all I'm doing here. $4,000. That's where Phoenix is. So this should be, y'all have to help me test this if you don't mind me asking you to. It should be connected to the local Phoenix server. And if you tweet and you mention Elixir ATX with an image, it should go. Yeah, it is. It should be. It's not showing up. Maybe locked. How about now? All right. So let's go tweet and let's see if it works. You can take a picture of me if you want to.
So
just basically mention Elixir ATX in there.
What hashtag we use?
mention TX.
Oh, yeah.
Just like I did here. This is what I use as an example, but it's pretty small.
That font's pretty small here.
We'll crash and burn. Did you? There it is.
That's pretty cool. That's
So
pretty quick.
that's it's fairly.
That's faster than VM. VMs take forever.
Yeah, so that's just a quick demo. If you want to try, I'll leave it up there for another second. Yeah, there's some other things.
Fire hose. You don't really have a fire hose here, right?
So the way that, and this is some outdated knowledge from when I did, you usually get about 5%, like a certain number of, but that's what you get. And if you limit it to a certain search query that doesn't go above that, or if you say, give me all of the tweets that are tagged with latitude and longitude, usually you can get 100% of those. So that's, if you go on my YouTube page and look back from like 2011 or whatever, I actually did a demo with something called TorqueBox where it pushes all the stuff. What?
Maybe I just can't spell.
It could be that, or a whole number of things. I went through a lot of different things here. I'm going to give you fair warning on this. If you do this for yourself and you pick a popular anything, you're going to get not safe for work images. So that's why I just ended up saying, make myself popular. So.
Is it? So I just did like Elixir.
Maybe the specific, maybe the replies, maybe you have to have a dot or whatever. Anyway, that's kind of what all that comes together to build. I wanted to kind of make sure that we could cover that before I jump right into like the description of how it all works. And I'm trying to learn Emacs, so you have to bear with me when we do this too. I wanted to start a flame war. Is that on there, Luke? Anyway, the conclusion's boring. OTP provides a basic building block. Elixir makes them easy to use. Phoenix is awesome. Phoenix channels and RethinkDB Changefeeds make a supremely unique pair. So I really showed you something really simple. Let me see if I can make this go to the other screen. So basically here, this is, and if you want to find this code, Josh has all this on GitHub. You can go download it. And I forked it and pushed up my little changes to it. The whole thing doesn't really work like he talks about in Elixir SIP, so I just kind of made it work for this demo. But what term you're monitoring here, and just let's kind of talk about what we mentioned earlier, the supervisors. This is a supervisor that monitors another supervisor. This is generated as part of Phoenix. And all he's done is added a task here, which is this Elixir tweet streamer, which just takes images. It just searches for images using the X-Twitter client. And then I modified it to push that into the RethinkDB database. And so there is nothing behind the scenes. I'm not using the broadcast functionality of Phoenix to push that to the browser. Let me actually show you. That's a cool part. That's called tweet channel. So this is a channel. I don't actually know how to make the font size bigger. Sorry. Control plus. No, it's anyway. hopefully at least the people at home can see that. But this is a channel. Get that down a little bit so we can see it. But I'm actually using channel and view here because remember I needed to render that HTML. Basically, this says on join tweets, as you can, the Chan tweets, this joins up here. If authorized, that just returns true right now. It generates that as part of the channel generators. But you would put authorization there. And it's actually, from my experience, it works with plugs. So if you just want to do HTTP basic auth and you're already authenticated, it passes that along and requires it. So this is kind of a tricky part. If you want to do something like some initialization that you want to do after they're joined, and you have to send this self after join. And what that does is sends a message to the process that's running that it'll actually, since only one of these things is running at once, because it's kind of like a GenServer, it'll process that after this function is done running. So this client will be joined to the state by then. So that's why I did that. And I actually handle info. That's just what you would see. I actually did not have a handle info in my demo for the GenOTP or GenServer. But handle info basically is a way to set up a handler for a message. Any arbitrary message that you would just send with send, like I did here. And then this sets up the initialization. This uses a task supervisor. I kind of went a little bit crazy with this just because I kind of think that's fun. Supervisor that Elixir actually provides just kind of provides some supervision for tasks, and you can use it for distributed computing and things like that if you don't want to like write your own supervisor, because you don't always need your own. You just sometimes want a supervisor that has these specific knobs set. So task supervisor is good for that. And then just use start child. That is what actually sets up the query. And so the key here is, since this is a task supervisor, this child here, this function, is going to be running in another process. So that'll keep on going, and this, will do no reply socket. The channel will keep on running as it is. And so this tweet stream is running in a different process. The Elixir friends client or database tweets, this is a query here. That actually is a whole other process. And if it dies, it'll be restarted because I specified restart transient. So it'll restart it if it makes it so where you can keep on using the channels. You don't have to have this one channel running, and have to open up another channel for something else. This, you can reuse that channel and just keep on sending stuff. It's not going to lock this up or anything like that. So something with RethinkDB is, I was doing, when I did this, it was National Hot Dog Day. So this is a way to do different filters. So this, that'll work just for looks anyway. So we wanted to filter on a specific example or a specific tweet. You could do it a little bit further, or if you wanted to only capture things that were so old, or whatever. This is just kind of like a function that's a filter. So you can do anything in there. You do have to use their lambda, but that, and I don't know well how it works behind the scenes, but I tried to break it and it did a pretty good job. Basically, you just access the tweet that you pass in, and then keep on using as long as you use the stuff that gets brought in with the RethinkDB query and lambda imports and requires there. You can go as deep as you want. And if you're not doing change feeds, then you can do aggregations and pass in functions for those aggregations. And maps and all that, and you stay in Elixir, you don't actually have to drop down JavaScript and write that. They do have JavaScript clients and Ruby clients and all that. So, but that's pretty much the gist of it. I could actually make that useful, but I don't. We would have to tweet a bunch more stuff and you'd see it work. But you know, it's kind of a cool thing. If you wanted to keep track of game events and you wanted to insert an event in this database, if it wasn't like let's say a perfect example would be an inventory for like an MMORPG. Let's say the way you would set that up is you would set up a channel and you would bind in your client to the event for changes to that inventory, and then you would just set up a filter here for the current user, which you can access from the session if you're using session-based, users, and then you could have any changes to that server-side inventory. You just have a query that says, select all of the entries from this table where the user ID is, food or whatever. And anytime that query changed, it would send you the new value, and you could update that. Or if something was removed, it would send you the new set. Now, it's up to you to kind of manage the updating on that, but that's all possible.
Question, what is the .d for?
That's a private. It just says it's a private function. So you don't want to export everything. That's pretty much all it is.
So I might have mistake. You said that this particular code spawns multiple processes?
Yeah, for every client that connects to the channel, it spawns another process. Now, you're probably thinking that sounds pretty heavy. Well, in Erlang, processes are about 2 kilobytes a piece when you start them. So you can spawn, I think the default limit's like, it's either 250,000 or 2.5 million. I can't remember how many.
It's like 400,000.
It's big. Yeah, you can just change it to whatever you want.
So I'm not very familiar with the open source community when it comes to Elixir. So a given good sized project, open source community, how many processes would it spawn? Are we talking tens of thousands?
Erlang is completely different. So it's like processes in Erlang are like objects.
Yeah.
So it's not uncommon to have tens of hundreds of thousands of processes. WhatsApp put 2.5 million per machine. So that's pushing the limits. I don't think they've reached 3 million quite yet in production.
You're going to have at least one code connection because all I/O is also handled through a process. So every client that connects is doing at least one process. And then on that, it depends how many other processes you want to current state for each user connection you have.
Yeah, right now this actually has 3. It really only needs 2 probably, but this task supervisor start link creates one. Because that actually creates a supervisor, and then the start child creates another process. Usually you would have the supervisor, some named thing that you're starting this process in, and have it just running one. There's no point in running multiple supervisors for this, at least.
You almost always want a supervisor, even if you think you would, because it helps with you can get overloaded, or you can get you don't have to catch many exceptions, and also
There's a little thing you don't want that process.
yeah. And the thing it can do is you can have it print out better error messages when they do crash if you have them misversion.
So a bare process is an unsupervised process.
Yeah,
And,
so
and no one's there to clean up after them. Things die, so that's why you want to.
Is the process name like threads?
Yep.
So
but green. So in Ruby, a green thread was bad in like 1.8.7. But in Erlang VM, they're called processes because they're isolated, unlike a thread would be. So the way the scheduler works is each CPU core by default gets a scheduler with some extra schedulers on the side for like C extensions. That scheduler works like a scheduler for your OS processes and it time slices them preemptively. But because Elixir and Erlang is immutable, they can be actual processes that are isolated. So like it's very fast to bring them up and tear them down because there's no shared state like there would be with a thread. And so once the process isn't used anymore, it can just be garbage collected. You can wipe it out the way OSs wipe out process everywhere.
So speaking of garbage collection, another unique part about Beam, the Erlang VM, is that the garbage collection runs on the process level. So it doesn't really run globally. You don't have a stop the world. You have, oh, this one little small process that's 10K worth of state. Here's a GC that might.
Well, no, it won't delay the other threads or the processes.
Right. No, I'm not saying. I'm saying for that one process, it'll run GC on that after. Right.
Okay.
So does that mean that the GC runs all the time?
I don't know a whole lot more about the GC. I think it's kind of one of those black arts like it is in JVM. I did make a discovery today about the binary area, and that gets garbage collected differently. So there's some interesting nuances to how that works, but they built it that way so where you can do kind of soft real-time operations with it. It won't, you don't have to deal with these humongous 100 millisecond everything stops type things.
Yeah, the soft real-time means that, unlike hard real-time where you can't go over a certain number, soft real-time means there's a fuzzy boundary. So like, you say 20 milliseconds there, once in a while it'll go a little bit over. And you can read the actual docs to see what it means specifically. Like, it's that sort of thing.
Yeah, the way they do it is, so typically the beam is running bytecode, right? And not necessarily assembly, but running bytecode, right? So you're in your compiled module is the actual beam bytecode. So I forgot what the name of the unit is, but after it runs so many units,
Reductions.
Reductions, right?
Yeah.
After it runs so many reductions of that bytecode, then it swaps it out for another process.
Reduction is about, you can think of it as like a function call. It's what the accent is, I guess. So like every function call, or like every like addition would be one reduction.
What else?
Good questions.
RethinkDB is the whole raft thing. For the people that don't know about that, it really allows it to do automatic failover across sites. If you want to do across sites, but really, a lot of people just do one data center for latency. I don't know what the effects of it on that. I've never deployed it in production, but that's really cool that you can spin up 10 nodes, and if one of them dies, it'll automatically fail over to the other one. Right now, you have to manually fail it over, but the beta, things like 2.1 or something like that, does the auto, and it's Jepson tested internally, I think.
What's the back? What's backing it?
C++. Oh, persistence. I'm not sure. I'm not sure what
Like
it
I
uses.
just reading it kind of the kind of counter indications of when you might want it would be like you want like full ACID constraints and that kind of thing. What do you know about it in terms of that level of kind of reliability?
Well, I know it's atomic on the document level. You don't have like transactions or anything like that, but really, we don't realize in relational databases how often we make trade-offs because we've been doing it for so long. So in some of these, a lot of the newer object type databases, document databases, you just kind of organize your data in a little bit different way, and you can kind of get a lot of the consistency guarantees that you want.
So this is the kind of thing that you would look at. I mean, I'm a huge proponent of like I love Postgres and ACID compliance, but I'm also a big fan of alternative data stores, but a second data store. So it's this kind of thing. So is that
Data, maybe just as like a quick tracking layer. I mean, I think it's fully capable of being the main backing store. But if you just wanted to, if you already have an app, you wanted to use it, let's say you wanted to have use it as like a queue and use the change feeds to push stuff up, or just maybe use Postgres for user registration and standard bog standard stuff, and then use this for the user's inventory. That would just be a document
But to me, it
inventory.
seems like, I mean, so anything I want to keep, like, I suppose Mongo's got its problems, right? A lot of those come from like level write lock and its lack of, kind of like full ACID compliance. So where does Rethink trump that? I mean, obviously the change feature is like a really interesting feature of Mongo. Doesn't change, right? So
Yeah.
that's what is there anything else in terms of like that level of work?
So with Mongo, Meteor JS, I don't know if you've seen that, but they actually use a feature of Mongo. I believe it's like a replication feature to kind of do some of the same real-time updates as kind of what I showed here, but it's the whole stack is Mongo. So it is possible to do stuff with that, with Mongo. I think really this is just kind of an alternative. I haven't really used RethinkDB for a long time. I don't know a whole lot about it. I just kind of saw this and I was like, man, this would go great with Elixir because you just create a process and just sit there for events and push it up. So as far as like deploying in production, I haven't really had a lot of chance to do a whole lot of research, but some of the things that make me feel safer is that the drivers, the client drivers, they are safe by default. Instead of you having to check with Mongo, you have to do the check for errors or whatever after every message for like a safe mode. At least you used to have to do that. I think they changed some of that up recently.
Right.
But I think it just is it's not as it's not as widely deployed as Mongo. I'm sure there's issues with it. But it seems like they're kind of targeting a different sweet spot than Mongo. Because Mongo started out as like a startup, they were going to do all this stuff, and then they're like, no, that's not going to work. We're just going to do a database. And so I think Rethink is a different story than that. And a lot of the user interface for it with let's see if I can swap to it.
Oh, it didn't show up there. No.
Sorry. So this is the RethinkDB default. This is what you get, and so you can see your cluster performance. One of the other big things is real time is like a first class citizen. That's how they built this, is real time. The clustering and high availability, to me, that seems like it was designed from the get-go. And then the tooling for it is a lot better. The query language stuff that I showed earlier, I think that's pretty cool.
I think I missed that part.
So basically, you can go here to Data Explorer and, I can get everything out of here
So, like,
in JavaScript, but I can write it in Elixir, I can write it in F#, whatever.
so like Mongo kind of claims, I think, that some of those things, like clustering and whatnot, that was always kind of like always when I first started using Mongo, it was kind of like that was their big thing. It was like free sharding and stuff like that, which didn't work out so well.
Well, see, the sharding wasn't even there from the start. Now, I don't know if it's always been there for Rethink, but I remember when it first came out, it was like, oh, this is awesome. And then people deployed it in production, and there were a lot of issues with it.
There were a lot of bad days. So with Rethink, like where do you, and you may have already mentioned this, but like where do you see it in the stack? Is this something that you just do a brief run through of their documentation on their website? Like, is this something you see like kind of like replacing like the channels of Phoenix in terms of the communication layer, or is this something that goes over the channels?
This goes over the channels.
Okay.
So basically, the channels are just kind of a way to communicate with the client. And in the channel, all I did was create a process that sends things back over the channel.
So it's not like Meteor where you've got clients connecting directly to the database. So you're just kind of hoping to right now figure out a way to execute.
Yeah. Now, that is one kind of weird thing about this is how they don't really provide security at all. It's up to you to secure it how you want to. I mean, they just put a proxy in front or, whatever, firewalls, It's up to you. So it's very unopinionated in that. I guess they think that you can solve it better than them, but it's probably going to lead to a lot of people, if it gets popular, just having rethink just wide open without even thinking about it. But I mean, people do that with Redis and Memcache. So, but I think you can use it as a full replacement for a primary database, as long as you're aware of the different trade-offs. Because, I mean, a lot of applications we have these few little simple things that we need to persist state, and we want it to be highly available because if it goes down, then we lose money or people hate us or whatever. And so,
like document updates, I usually go back to Postgres. If it doesn't, so it's becoming 995, document updates, within the document, right? You can only do whole document updates if you're gonna update a field in Postgres. That's one thing Mongo beats it on, is I can update a field in my document deep in a tree without actually having to pull out the document, update it, and write the whole thing back.
I don't think you can write the queries to do whatever you want, and they run on the server. So I don't know their API very well, but since it all runs on the server, you're not having to pull all that data to the client and change it and then push it back. You can actually make changes to the document atomically and make atomic changes. I think you can do some of that with Mongo. Oh, that's what you were talking about, is Mongo. Yeah.
Well, I guess I'm kind of confused then, where the client, when I think of the client in Postgres, the client is actually server. Client server, which is JavaScript of the browser to my server, right?
Well, to me, the client is whoever is building the query, whether it's from code or whatever. The client would be a Rails app.
Yeah.
Whoever's using this, whoever's connecting to the Postgres or Rethink server. That's what I mean.
Yeah, I think that's kind of.
So you don't have to ship that data all the way there. If you want to run a function that changes everything, like on Postgres, I haven't used the JSON stuff, but usually you don't have to pull all the data from Postgres to update some rows. You just say update where whatever, and you're done. So you can do that same type of thing with this.
Yeah, I guess probably where I'm confused is it seems like a lot of the NoSQL solutions like Meteor and MariaDB intended the updates actually run from the browser to the database, and I'm not clear where Rethink sits in that kind of structure.
Well, Meteor is kind of it's a whole different paradigm on how to do web dev and apps. So what I've showed today is a lot more traditional. All it's doing is we're making some changes somewhere. It may not even be an Elixir app. It may be, a COBOL app that somebody wrote a binary driver for RethinkDB, and they're doing queries with it. And that a change is made, and we get an update here because of the Changefeeds. And so, if you wanted to make a full loop, so where, you have JavaScript client code, which changes, so, Angular, Ember, whatever, whenever an object changes, you could have it sent across this to update, and then it would go out to everybody that was subscribed to it, and you could have it come back in and update. You could do that same sort of thing with Phoenix, but Phoenix is kind of like
you got regular control over there in the Phoenix layer, right?
Yeah, and authorization, authentication, stuff like that. You still have server-side control. So maybe, this could be a good middle of the road, because I think Meteor still scares a lot of people. I haven't given it a good look recently, so I can't give an honest opinion about it. I know when it first came out, there was no authorization or authentication yet, so it's like, just do whatever you want. And so having that as an afterthought.
There's the pub somewhere for Phoenix to get one Phoenix process to talk to another. So stuff like Postgres, you probably could also hide the fact that you're actually talking to RethinkDB even.
Oh yeah.
And just have them talk to each other that way.
So there's a RabbitMQ one. I think there's a RabbitMQ. There's a VernetMQ, which is MQTT, and then there's Redis for Heroku, where they've done that. as a back end, but you wouldn't really get any of the query and filtering features unless you provided a different type of API or something to still get at that. So I think Rethink provides some value, but one of the ways that it is different from the Notify with Postgres is that Notify only runs on one server. That's something that I was like, oh, this is so awesome. You can build all this cool stuff, and then Notify just runs on one single instance. So you're limited to like master-slave type situation.
We were looking at databases over a year ago. The Rethink was pretty new back then, so it lost the Couchbase. Couchbase is pretty good. I have a lot of what you're talking about.
Does it have the real time, like the streams and stuff like that?
It had everything.
Yeah.
But yeah, I'm gonna go back and look at RethinkDB after a year and a half.
Yeah, it's worth a look, and I think it's really easy, like Elixir is, to just jump in and get started. You just do brew install if you're on a Mac, and it's running on loopback. Now the client for Elixir is under development, so that's something to be aware of. But this stuff worked, and to me, this is like, for it to work at this early of a stage, I think that these two things can be combined together to build some really cool stuff. So just, play it out, play around with it in your pet project. There's no, you don't have to do a schema or whatever if you're one of those people that hates doing that. You just dump that into it, and, you can pull things out by the table and have different, things. So you have to be aware of that. But it's got a lot of really cool kind of developer focus and ops focus. The whole clustering, that being just available out of the box, setting up HA proxy with Postgres, whatever flavor of the month that you use to make that highly available. That's just not something that, as a developer, you really feel comfortable doing unless you've done it a bunch of times before. So for a lot of people that are just like the first, second dev in their shop, don't have a lot of ops background, I think RethinkDB is probably a pretty good way to just set up a cluster of servers and go with it. And Compose, I don't know if anybody knows what that is. They just got bought by IBM, but they offer Rethink, Postgres, a couple other stuff, hosted solutions. So if you want to just spin up RethinkDB and EC2 and have access to it, then they provide that.
Is that part of their movement stuff?
It is now. Yeah. Last time I checked, and that was the day that IBM purchased them or acquired them, it said that it was free. I don't know to what extent, because it was like $16 or $20 a month for that. But it says it's free. It's, even being IBM, I think it's some cool stuff. Anything else? Favorite colors?
Appreciate it.
Twitter client and all,
Do what?
use that Twitter client and all, protect.
The Elixir Friends app.
Yeah.
I have a humongous e-ink display that just keeps me, it's low power, I save energy.
That you grab. You like the friends?
Yeah.
Thanks for taking time.
Yeah, I enjoyed it.
Presentation, very good.
Thanks for attending, people at home.
Coco with my hand home.